start conference off with a research lecture. And I'd like to thank Dr. Z for being here with me, helping me with this presentation, presenting with me so early this morning. So today we're going to be talking about data, essentially continuous data, and how to present your data by measures of central tendency. So the point of this lecture and the many research lectures to follow this year are really to dumb down the methodologies to make research a little more approachable, a little less intimidating, with the hopes that you may pursue research opportunities in the future. Okay? With that said, I imagine that most of you will continue on more so as readers than investigators, but it's still important as a reader to understand the methodology. That way you can assess the quality of the papers you're reading, the validity of what you're being told. Okay? So today, again, we're going to focus on the data, and we're going to determine with you, with actual raw data, how to appropriately present your data. So let's give you an actual research question. Okay, Dr. Z and Dr. Baird and I, we're looking at lactate as a marker of mortality and trauma. Okay? So let's say that we have two groups that we want to compare. We'll have a survivor group and a non-survivor group. Okay? And we collect all of this data. What do we do with all of our numbers? Hopefully we have thousands of lactate levels that belong to thousands of patients. Now what do we do with that? How do we define our groups as survivors and our non-survivors? Well, if you had asked me, and I think if I asked you today, you would add up everything and divide by n, right? That's the mean. We use means almost instinctually. It's something we do every day. But means are only one measure of central tendency. There are actually three. You're familiar with the other two, medians and modes. Today we're going to be focusing on means and medians, and we're going to share with you, actually determine with you, which is appropriate to use and when. Okay, so let's go through our actual patients here. Okay, so let's say that these are our non-survivors, and we're going to give them lactates. So these are the lactates when they arrive to the ED. Okay, you add them up, you divide by 6, you're going to get their mean, 3.2, which is great, because now you have this number that defines your group, and with this number you can now compare this group, the non-survivors, to another group, the survivors, right? So very useful. The thing is, means are not always the appropriate measure to use, especially in the case of outliers. So means are great, they take into account all of your data points, but they can misrepresent your data in the setting of outliers. And by misrepresenting your data, it might be easier for a researcher to come up with a statistically significant difference between groups, right? Which is kind of a false, misleading difference. So let me give you an example. We're going to change the last lactate to 151, non-physiologic, but he's going to be an outlier, okay? And then when you calculate your mean is now 28.4. And to the researchers, that sounds like amazing, right? It's so great because you're definitely going to have a statistically significant difference. But in the case of outliers, as I said, means are not always appropriate to use, can misrepresent your data. Medians, however, are going to be less sensitive to outliers. Because medians, essentially the value at which 50% of your data points fall below, 50% fall above, it doesn't take into account how far below, how far above, to the extent that means do. Okay? So how do you know if you have outliers? Well, if you plot your data points along an x and y axis, you would get something like this. This is a histogram. This is actually in a bell-shaped curve. This is what you would consider normally distributed data. Okay? And with normally distributed data, you can use means, because means and medians and modes are actually the same in this case. Okay? So if you were to have a lot of outliers, as you might appreciate when we actually do the demonstration, you will have skew in this graph, in this histogram, one way or another, or you could have a change in the amplitude of kurtosis. And in those instances, medians should really be used. Okay, so now we're going to switch over to Good morning, everyone. So Dr. Z is going to actually go through this data here. He's going to show you an example. So we have, okay, so So we're going to start off.
So this is an actual database of one of the studies that we did. So we have the numbers, and as Andrew said, this is all about how you present your data, and how you present your data will determine what the statistical test you can use in the future. If your data is normally distributed, you can use mean and standard deviation, and that comes with a set of statistical tests like t-test or ANOVA. But if your data is not normally distributed, then you cannot use t-test and ANOVA, then you have another set of statistical tests that you can use. So here, for the first thing that you do when you have a set of data, let's take age for now. Andrew talked about outliers, right? So the first thing you do, you sort your data to make sure there are no errors in your data set. So here, age starts at 9, goes all the way to 95. If you had a patient here that was 200, if it had a number 210, then you know that's an error. You go back to your original data sheet and correct that, right? So the first thing to do is that you sort your data. And now, in order to see if the data is normally distributed or not, we do a histogram. To do the histogram, you need to determine what you want on your x-axis. It really, the interval of the data really doesn't matter what you pick, but since we have age here, let's do 10, 20, 30, 40, 60. So these are the intervals on the x-axis. You can pick 10, 30, 50, 70, it really doesn't matter what you do. And then we go to data analysis.
So as you guys can appreciate, this is our histogram. Would you say that you have skew in this histogram in comparison to the prior? Yes. I would agree with you. So in this instance, medians would be appropriate versus means when you're presenting your data.
So most of your data is skewed to the right, and this is not normally distributed data. You really don't need a statistical test to tell you this. You just look at the data. It's not a bell-shaped curve. Another thing that you can do here, you can data and actually calculate your stuff. You can just do a quick calculation and you will see that your mean is 34, median is 31, your mode is 20, right? We said if the data is normally distributed, mean, median, and mode will all be the same. That straight line in the middle of the bell-shaped curve would be your mean, median, and mode. Here, all of them are different. This also gives you kurtosis, the degree of kurtosis and degree of skewness. And the statisticians have certain criteria, and they will decide based on the skewness, based on the numbers, how whether the data is normally distributed or not. But for example, the skewness should be close to 0, and that's for a normally distributed data. But you really, as I said, you really don't need a statistical test to tell you that this data is not normally distributed. Therefore, the way you present your data should be by medians and not means.
So as a reader, if you're going through a paper and they're using means, but they're not describing to you how the data is distributed, that's an issue, right? Because if they're using means and the data is not normal, then they can again get to statistical significance falsely.
Yeah, so the statisticians prefer researchers prefer using t-test and ANOVA, mean and standard deviation, because it's easier to get the statistical significance, as Andrew said. The non-parametric data, when you use median, they are more difficult, they're more strict, and it's harder to get the statistical significance. That means you have less chance of false positive results. Now let's do the same thing for lactate. Again, the first thing we do is sort the data. To make sure the numbers are correct. So we have lactate from 0 to... So this is a good reason for checking, right? There are some errors in entering the data. This is so you have to get rid of it. And this one, we don't know what it is because it could be an error, or it could be 9.6, or it could be another number. So you have to go back to the original data and check this. For the sake of today, we just delete it. Now let's look at So again, for the x-axis, we have to decide the bins. I would put 0.05. What do you think? We have a lot of outliers, and your data is skewed to one side again. This is not, so lactate is not a normally distributed data. Just to make sure. Here your mean is 2.8, your median is 2, your mode is 1. They are not the same, and the skewness is 3.04. Remember we said it should be close to 0. But you don't need a statistical test to tell you that this is not normally distributed. One more I want to do just to show you another example, and then we will move on. Sort the data. Again, you have a heart rate of 8, right? That doesn't sound right. You have to go back to your data and check these to make sure they are accurate. But for here, we just delete them. see this one looks better, right? See, it's almost a bell. You can never get that beautiful bell shape, but this is close enough. And this is most likely an appropriate set of data to use mean and median. Okay. And last thing we do, just to show you descriptive statistics. Mean is 86, median is 87, and mode is 90. Almost, they're very close. So this is a normally distributed data. As Andrew said, this is important because when you read the paper, you have to make sure that the analysis that they're presenting to you is correct, right? In order to have the analysis correct, they have to use the right statistical test. They have to use the right measures of tendency. If they use mean and standard deviation, they have to tell you why they did it and whether the data is normally distributed or not. A lot of the statisticians recommend that you just forget checking for the normal distribution. Just use median and quartiles for all data set. Because if you use more strict statistical test, that's okay. If you use the wrong statistical test, that's not correct. So if they use median and quartiles in the test, that's okay. But if they use mean and standard deviation, they have to tell you whether they tested the data for this normal distribution.
Thank you, Dr. Z. Now we'll have Dr. Sinner. Did you